Hi everyone. Today I am going to do a video for you that covers the second half of lesson 6-6, beginning with the section on trapezoids. I am on page 429, and if you would turn there in your book with me and let's walk through this information together. This lesson is just too long, I think, for us to cover in class and have any time to answer your questions and that kind of thing. So that's why I'm doing a video on the second part of it, and that will equip you to have the whole lesson under your belt. So again, this is lesson 6-6, and we're talking about trapezoids. So as you see, right where I'm holding the camera, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. Let's look at that in the picture right here. Sorry, reaching across. Okay, each of the parallel sides of the trapezoid is called a base. So we don't call the two parts that aren't parallel bases. We only call the other two sides bases. The non-parallel sides are called legs. So you see that right here. We have the two parallel bases with the parallel signs on each base, and then the legs are the third and fourth sides. We also have base angles. Base angles of a trapezoid are two consecutive angles whose common side is a base. So two consecutive angles whose common side is one of the bases. And here's another set. Two consecutive angles whose common side is one of the bases. Now we're going to move on to learn about isosceles trapezoids. In isosceles trapezoids, the two legs are actually going to be congruent. So let's look at that. These theorems are true for isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So you're going to have the two angles congruent that run along one base, and the two angles congruent that run along the other base. So B would be congruent to C and A to D. All right, the next theorem tells us if a trapezoid has one pair of congruent base angles, and what that really means is if you only know that one pair is congruent, then it is still an isosceles trapezoid. So if you know that one pair of base angles on a trapezoid is congruent, then you know that it is an isosceles trapezoid. All right, and the last theorem for isosceles trapezoids says if a trapezoid is isosceles, then its diagonals are congruent. And what the theorem actually says is a trapezoid is isosceles if and only if its diagonals are congruent. So that's a have to. So in this case, AC would be congruent to BD. So again, our three theorems are if there are two sets, or let me restate that, if it's a trapezoid, then there are two sets of congruent base angles. The next one states, if you know that there's one set of congruent base angles, it is an isosceles triangle. So in other words, you don't have to know that both sets are. As long as you know that one set is, then it's an isosceles trapezoid. I think I said triangle in the last sentence, and I apologize, but trapezoid is what I meant. And lastly, it is a trapezoid if and only if its diagonals are congruent. All right, let's flip the page to 429 and let's start looking at the problems where we get to apply all that we have just learned. So these are isosceles trapezoids. We know it's a trapezoid because we have two bases that are parallel. It also has to be a quadrilateral. That's something that we didn't talk about on the previous page. So it's a quadrilateral with one pair of parallel bases and with at least a set of congruent base angles. Actually, both sets are congruent, but you have to know that a set is congruent, and with congruent diagonals. And you can tell that this is isosceles because they have drawn this line, XW, one leg, congruent to the other leg, YZ. All right, so they want us to find the measure of angle Y. Well, let's look at our trapezoid. The measure of angle Y. You can see that I've already done some writing in here. But remember, if this trapezoid is isosceles, then the base angles are congruent. So if the legs are congruent, then the base angles are congruent. So if W was 117, then I also knew that Z was 117. Well, then I could go on to figure out why, because I had two parallel lines crossed by transversal YZ or ZY. In that case, that means that I also have same side interior angles that are supplementary. So I could simply say 180 for the supplementary part minus the 117 that we knew equals 63. So again, walking through that one more time, if we knew that W was 117, then we knew that its other base angle was also 117, the one that was consecutive to it. And then we also knew that angle Z and angle Y are supplementary because they're same side interior angles in between these two parallel lines. And so we simply said 180 minus 117 equals 63. All right, let's move on to the next question. We want to know the measure of RT. So let's come and look at actually, that's not what we want to know. We're told RT. So looking at this, I labeled that RT is 24.1. We're also told that QP, just this short part of the diagonal, is 9.6. You can see this in example 3, letter B. So they want us to find PS. Well, PS is right here. So it's the missing part of diagonal QS. Well, remember what we know about the diagonals in trapezoids. They are congruent. They must be congruent. So if RT is 24.1, which we are already told, then QS also has to be 24.1. So we can simply say 24.1 minus the 9.6, and that will give us PS. And that answer is 14.5. All right, let's look at a check it out. This is check it out 3A. And it says find the measure of angle F. Now you can see I've already done this work, but let's look at it together. We are given angle H. We are told that it's an isosceles trapezoid because the two legs are congruent. Therefore, we know that the two base angles down here are congruent. So if this one is 49, then E must also be 49. And going back to what we did before, when we have two parallel lines crossed by a transversal, we have same side interior angles that are supplementary. So to find F, all we had to do was say 180 minus 49, and that gave us 131. And let's look at one more, and that is, check it out, 3B. All right, we are told JN is 10.6, and you can see that I've labeled that. NL is 14.8. Now we know that JL has to be congruent to KM, and they want us to find KM. So you simply need to add JN plus NL to get KM, and that gives you 25.4. All right, that's the end of this video, and I will get ready to do a second one.